All right, in section 10.2, we're going to talk about parametric equations and parametric curves as well. So the idea behind this section is that previously we've talked about a graph having a single equation, something like y equals 3x plus 2. We're going to call that the rectangular equation because it gives rise to a rectangular looking coordinate plane. But it has two variables, x and y. And obviously, most of the time we think of one as the input and the other is the output. Well, now what we're going to do is we're going to add a new variable. And therefore, we're going to represent that same graph with multiple equations. Specifically, we're going to have an equation for finding y and an equation for finding x. So something like this, y equals t plus 2 and x equals 1/3 t. So you might want to ask, well, why would you ever want an extra variable? What do we get out of this? Well, what we get out of this extra variable is the ability to talk about when the graph is at some point. If you think about a y equals 3x plus 2, that gives you the x position and the y position. Now adding an extra variable, and most of the time that extra variable is going to be the letter t. Sometimes it's the letter theta, but most of the time it's going to be letter t. That extra variable allows us to talk about when the graph is at a certain point. All right, so that's why, by the way, that extra variable is often called t, because it's talking about time in some way. And you could see that how the extra variable would be important if you were going to look at, for instance, the height of a bullet shot at a target. So it would have a height and a distance, and you would want to know not just where the bullet goes, but when the bullet hits a certain point, especially if you have maybe two moving targets or something like that. You can, look at graphs of that. If you Google that on the internet, you can see, the range of bullet motions. Here's one such graph here. A 9mm shot goes this way approximately. And again, if your target is here and they're moving left to right, obviously if we're thinking about 3 dimensions, we want to know where exactly that hits, but also when it hits that spot. So nice things, parametric deals with nice things. Now, if f and g are continuous functions, the equation x is equal to a function of t and y is equal to some other function of t, those are called the parametric equations. And then those plus together with their actual graph is called the plane curve. So if you've seen the word plane curve, that's the graph of parametric equations. Now, one thing I haven't mentioned yet either is that since we're defining x and y separately, now x does not necessarily have to be a function of y, and y does not need to be a function of x. So this also allows us to deal with non-functions. It allows us to deal with, for instance, conic sections, parabolas on their sides, and things of that nature. So what are we going to do in this section? First off, we're going to sketch the graph of different various parametric equations. We're going to come up with that plane curve that I was talking about. Then we're going to do some changing back and forth between rectangular coordinate systems, just y equals a function of x, and parametric coordinate systems. X is a function of t, y is a function of t. And obviously backwards too. All right. And then in the next section, we'll deal with some calculus issues about parametric equations. So let's start by sketching graphs described by parametric equations. So I'm going to take x equals t squared minus 4 and y equals t over 2. And I'm going to graph that using what I would call a standard method. When I refer to the standard method, I just mean we're going to build a table. We're going to plug in various values for t, and then once you get those values, you'll get some values for x, you get some values for y, and then you can graph it on a some sort of a graph paper if you'd like. Now, whenever you do this, it's important to pick pretty good values for t, so make sure you pick some negatives, positives, things that are all over the board. So let's pick some negative numbers. Let's take t as, let's say, -4. I'll do t as -2, t as, oh, I don't know, 0, and then maybe 2, 4, 6. Maybe those are my values for t. And then just plug those into the equations. When you plug in a -4 in for t, -4 squared minus 4 gives you an x of 12. When you plug -4 in for t in the y equation, you get that y is -2. So you plug in -4 there, plug in -4 there, and you get 12, -2. Now this is just the standard point, 12, -2. So on a graph, you just graph the point 12, -2, and make your point there. When you plug in -2, I got x is 0, y is -1. If you plug in 0, you get -4 for your x. Hopefully you guys are okay with that. Plug in 0 here. 0 minus 4 is -4. Plug in 0 here. 0 divided by 2 is 0. Plug in 2, you get 0, +1. Plug in 4, you end up with 12, 2. Plug in 6, you end up with 32 as your x value, and 3 is your y value. Now, if you want more points, by all means, go ahead and plug in different values for t. Obviously, this kind of jumps from 0 to 12. That's a big jump. Maybe we'd want to plug in a -3 or something like that. So maybe you add in another, whoops, add in another line to your table and plug in -3 or plug in +3 or whatever you'd like to do. Let me plug in -3 and +3 just for the sake of doing it. -3, -3 squared is 9, minus 4 is 5. And I got -1.5 or -1.5 when you plug in -3 for t into the y equation. And then +3 would give you another 5, but a +1.5. So you go ahead and graph that. When you graph, make sure, obviously there's nothing to graph with its respect to t. You're just graphing the ordered pair 12, -2, 0, -1, and so on and so forth. So let me go ahead and do that. I'm going to do that in the Desmos calculator like you've seen before, like you've seen me use before. I've put a point here. Let me scroll out so you can see those nice green points. You can see you get points, and if you're going in order, what's happening is that, well, if I started here at this where my cursor is, that point, go back and hit this point, and then they're going back out in this direction. So if you were to, for instance, connect those dots, you would end up with something that looks like that. And obviously that's probably some sort of parabola pointing to the right. Let me see if I can draw an arrow. Yep, that's not going to be very nice, but that's okay. So it would be smoother than what I can draw, but it's some sort of a parabola pointing to the right. Okay. Again, it would have been smoother if I had more points in there. And obviously here it almost looks like you are, since I'm just connecting dots there. It doesn't really, look nearly as smooth as what it probably is in real life, right? So there you go. That's the idea. So that's method number one. Again, that's sort of the classical method of how to sketch parametric equations. Now we have the advantage of having a calculator. So our TI-84 will actually graph parametric equations for us as long as we know how to input those things into our calculator. If you go to your the TI-84 and hit the mode, you go down until you see the difference between function, parametric, polar, and well, my calculator has function, parametric, polar, sequential. You want to be on the parametric, PAR on some calculators, PRA on other calculators. Some calculators say parametric, but it's always the same thing. It's in the function version. So go to mode, down a couple, and parametric. So as I said, when I hit the mode function, my calculator screen goes to this, and I go from function to parametric. So go function to parametric, hit enter when you have your cursor at parametric, and then hit the y equals button. Now, once you hit the y equals button, your calculator is going to look like the following. By the way, you know where the y equals is, it's right there. So the calculator is going to look like this, x1, and then this is sub t. Now, some calculators don't have this, some do, that's fine. But you have x and y, and notice there's one slash with an x and a y. So all you have to do is type in the equation you want. Now, I'm going to type in the equation that we had, t squared minus 4, and then t divided by 2 in for the y. Now, when you do that, make sure you're using the variable t and not the alpha letter t. So what I mean by that is to use this button right here. Normally, when you're in the y equals mode, it'll come up as an x, but when you're in the parametric mode, hitting this button right here next to the alpha comes up as a t. And so you're going to hit t squared minus 4. And you don't want to use the alpha and then the letter t, which is, what is that? Well, don't even worry about it, but it's alpha 4. So do not use alpha 4. Use this variable feature for t. So that's what I've input. And when you do that, again, I'm inputting the exact same thing that I've input here. X equals t squared minus 4, y equals t over 2. Your calculator is going to know that this is a parametric equation scenario where x is defined here and y is defined here. Sometimes you'll have to adjust the window a little bit. So sometimes you have to go into the window and adjust that, but we'll see how this goes with mine. So zoom, I typically do zoom standard. When I did a zoom standard, what I got was just the positive y values here. So you'll notice I didn't get the bottom half of the parabola. That happens sometimes because, like I said, the window is not right. A lot of times, especially with these parametric, the t is set to a minimum of 0, and the t minimum is 0, the t maximum is 6.28. So if you just hit the window key, which is right next to the y equals, then you can adjust your t. Again, window button is right here. And then I adjusted my t to a -10 and my t max to a +10. So minimum t is negative, maximum is +10. It started out as 0 to 2 pi. So when I did that, I got the whole parabola that I wanted to right there. Okay, so there you are on parametric graphing. So you can always use your calculator to sketch that if you like. In fact, that's how I'm going to be doing this from now on. I want you to try now to sketch, instead of using the table, I want you to sketch x equals 8 cosine t and y equals 8 sine t, and try to do this in a way that you adjust your window so you see the whole graph. Okay, push pause on the video and go ahead and do that. So when I graph that, I got this shape. Now, actually, this kind of looks like an ellipse, but it's actually a circle because of the window that I have. I have on the standard window, which goes an x value up to 10 and a y value up to 10. But you'll notice that because the window has more space left and right, those units are actually wider than the up and down units. So the x units are longer than the y units here. If you want to make your window more square, you can just hit zoom and then square, or you can just play around to the window. But that is actually, so zoom 5 is the square feature, and if you hit zoom 5, it will redraw this as something that looks much, much more like a circle. So mine gave me this. Now, either way is fine to do. You don't always have to make your circles look perfectly circular shaped or anything like that, but you should be able to recognize when you do get that oblong thing to be able to say, oh yeah, that goes out 8 units on the x, 8 units on the y, so this is a circle of radius 8. And notice that it's centered at the origin of 0, 0. So 8 cosine t, y as 8 cosine t as the x and 8 sine t as the y gave me a circle of radius 8, centered at 0, 0. I want you to see what happens with this equation. Sketch these curves using your calculator and see what you end up with. So this is what I ended up with. 5 cosine t minus 1, 7 sine t plus 3. When I graph that, I end up with this graph, which is an ellipse. By the way, this is the square units. So this is an ellipse. And if you notice where this thing is centered at, it's centered at -1, 3. So right about where my cursor is, that's the center. By the way, that is no coincidence that that happens to be what we've skewed the x by, -1, 3. And then -1, and we've skewed the y by a +3. Okay? I want you to do one more. I want you to sketch this. X equals 5 secant t minus 1, and y equals 7 tangent t plus 3. Go ahead and sketch those with your calculator and see what graph that gives you. All right, obviously there's not a secant button on our calculator, but secant is 1 over cosine. So you can, instead of 5 times secant, you can do 5 divided by cosine minus 1. And then tangent, there is a tangent button. So 7 tangent t plus 3. Now my calculator brings up some weird shapes that look like this. Now it's kind of difficult to see what's going on, but this is actually a hyperbola that's pointed, well, this hyperbola over here is pointed towards the left. This hyperbola over here is pointed towards the right. And what they've done is they've included these asymptotes. So my calculator does that. Some calculators include the asymptotes, others do not, but this is a hyperbola. And if you notice once again, it is centered at -1, 3. That's precisely because that is right? We did 5 secant t minus 1, so that gave us the moving from -1 from the origin, and 7 tangent t plus 3, so that meant my center had to move 3 units up from the origin. Okay, so that's how to sketch parametric equations. We'll stop this video there.